Hello, my name is Paul Schwarzmeier and I'm currently doing the research for my dissertation at the Institute of Energy Systems and Thermodynamics at TU Wien. In the following few minutes, I'm going to introduce you to our research project 5D Industrial Twin, which focuses on the development of a digital twin framework for industrial energy systems. The consortium of the project 5D Industrial Twin consists of 2 research groups and 2 industrial partners. As developer of the exam control automation platform, our project partner Ewon contributes to the project 5D Industrial Twin with their expertise in innovative control tasks. As a globally leading steel producing company, voestalpine provides a lot of use cases for the application of sustainable and digital technologies in order to increase the efficiency and to decrease greenhouse gas emissions. As experts in the field of industrial information and communication technologies, the Institute of Computer Engineering contributes to the project 5D Industrial Twin in terms of information modeling and knowledge representation via ontologies. With their expertise in thermal engineering and the optimization of industrial energy systems, the Institute of Energy Systems and Thermodynamics contributes to the project 5D Industrial Twin by combining sustainable energy systems with optimization tools and digital technologies. The motivation of the project 5D Industrial Twin is to increase the sustainability and efficiency of industrial processes by utilizing thermal energy storage systems and to optimize and monitor their operation with digital twins. For the use case in this project, a LD process which is operated as a batch process at voestalpine has been chosen. The big problem with such energy-intensive batch processes is that their energy demand and supply do not overlap, which results in a lot of waste heat that cannot be regenerated. Thermal energy storage systems, in this case a vertical packed bed regenerator, are suitable solutions in order to enable energy regeneration in such energy-intensive processes. For experimental investigations regarding the suitability of LD slag as storage material in a packed bed regenerator, and of course for the implementation and experimental validation of a digital twin framework for a thermal energy storage, a lab-scale testrig has been erected in the laboratory of TU Wien. The packed bed regenerator as storage type was chosen because of its insensitivity to high dust loads of the process gas and its potential for high energy storage densities. The testrig has a diameter of about 0.5 meters, is 2 meters tall and holds 500 kilograms of LD slag, with a grain size of 16 to 32 millimeters. This results in a storage capacity of 55.2 kilowatt hours for a temperature difference of 300 degrees Celsius. Now let's start with the actual content of this presentation, including digital twins and our way to implement a digital twin for industrial energy systems. In a nutshell, a digital twin is a virtual representation of a real-world entity of which the main feature is the automated bidirectional real-time communication between the physical and the virtual entity. The main goal of the project 5D Industrial Twin is to implement and experimentally validate a functioning digital twin for an industrial energy system for the first time. The result of this project will be a platform which enables modern technologies like artificial intelligence, machine learning, predictive maintenance, fault detection and classification, and much more to interact with each other in order to make the most of their potentials. The modeling approach which has been chosen for this project is called the 5D modeling framework, which was first proposed by Tao, who used it for prognostics and health management for complex equipment. Our 5D industrial twin therefore consists of 5 different parts, which are the physical entity, the virtual entity, the data model, the service model, and of course the connections between these 4 parts. The physical entity is represented by the packed bed regenerator testrig. The virtual entity will consist of several simulation models which can be data-driven, physical or hybrid models. The data model will hold all the sensor data from the physical entity, all the simulation data from the virtual entity, as well as domain knowledge in form of ontologies. The service model will hold all the sub-services which are applied to the digital twin. Such services can be, for example, operational optimization, predictive maintenance, fault detection and classification, or a smart data service which cleans up and pre-processes the raw data from the physical entity. In this graphic, the system architecture and all the subcomponents, as well as their interactions with each other, are shown. The physical entity of the 5D industrial twin consists of the lab-scale testrig, which represents the real plant at voestalpine. The testrig is controlled with XAM Control, a software tool developed by the project partner Ewon. The data communication of the historical and the runtime data to the virtual entity is realized via OPC-UA and ontology-based data access. All this data, as well as domain knowledge about the process, plant equipment, topology and instrumentation, is stored in form of so-called ontologies in a semantically meaningful and machine-readable way. The just mentioned ontologies and the MQTT communication with the digital twins services is developed by the Institute of Computer Engineering. Efficient simulation models, optimization algorithms and many other services are developed by the researchers at the Institute of Energy Systems and Thermodynamics. For the development of simulation models, several modeling methods like data-driven and physical modeling are applied and combined in order to increase their efficiency and to enable methods like online model training, online model adaptation, online soft sensor modeling, and model-based fault detection, classification and prediction. Optimization models, including methods like mixed integer linear programming and stochastic optimization, are developed and applied to the digital twin in order to increase the efficiency and to decrease greenhouse gas emissions of industrial processes. Finally, I want to thank you for your attention, and if you would like to have any more detailed information about the project 5D Industrial Twin or other topics including digital twins or sustainable development in terms of industrial energy systems, Professor Hoffmann and I will be happy to answer any of your questions.